Hello everyone, my name is Dan the Tutor, and welcome to Lesson 3 of the Algebra 1 summer course. Today we're going to be focusing on factoring. This is factoring part 2. If you remember from last week, we were doing factoring, foiling, distributing, but today we're going to focus only on factoring. As a matter of fact, a lot of the problems that we're going to do today are actually pretty advanced, and you might not see until the end of the year. But as I mentioned before, factoring is the most important skill in all of math, at least from Algebra 1 to Calculus 1. So I don't mind looking at the hard ones, because if you don't see them today, you're going to see them eventually, and that's a promise. So let's get started with a little review from last time. So if you remember, I talked about this X method. This is the one where in the top you would write the multiples of C, where C is the last term, B is the second term, the 5, and A is whatever's in front of the x squared. In this example, A is actually just 1 because it's like an invisible 1 in front of the x squared. So you don't even need to write that. But on the top is the multiples of C. On the bottom, they need to add or subtract to B. And then on the left and the right side, these are the factors of C. And also, if you remember me saying, I don't use this method, but this is the method you're likely going to see when you're in class. And again, the reason why I don't do this method is because I think it's confusing. I don't think it's the best way to do it. The way I do it, if you remember, is I start out by looking at C, the negative 14, and I ask myself, what are the factors of 14? So I know for a fact there's 1 and 14. That's one pair of factors. Then there's 2 and 7. And are there any more? No. So it's just two pairs of factors. So the next thing I need to remember is this minus sign right there. That minus sign means there's one of each. There's one positive number, and there's going to be one negative number. So this could mean positive 1, negative 14, or negative 2, positive 7, or something like that. And then the last thing I would say is that it needs to add up to positive 5. So for that reason, I'm going to say what factors add up to positive 5, where one's positive, one's negative. If I do 1 minus 14, that's negative 13, so no. And 2 minus 7 is negative 5, or if I do the opposite, 7 minus 2, that gets me the positive 5. So what I'm saying is, if I set up my factors like this, and then I fill in the blanks, the fill in the blanks are going to be plus 7 and minus 2, because that's what's going to get me to the positive 5 in the middle. And I would also say that you can check your answer by foiling. If you remember what foiling is, this is where you have, for instance, x plus 2, x plus 7 times x minus 2, and then you FOIL, so it'd be x squared for the first, the outer is minus 2x, the inner is plus 7x, and then the minus 7 times negative 2 is minus 14. And this gets you the same thing, x squared plus 5x minus 14. Any questions on that? Okay. So now for the examples, we have x squared plus x minus 2. Let's start with this one. Again, the factors are 1 and 2. So that means if I want to choose the right factors, again, it's going to be one of each because of that minus sign right there. And I also know it needs to add up to positive 1 because remember, there's an invisible 1 in front of that x. So it's either, well, there's only one pair, and I know it has to be minus. So basically, it's either 1 minus 2 or 2 minus 1. Since I went positive 1, it is going to be 2 minus 1. So that means the factors are x plus 2 times x minus 1. And there we go, a nice easy one to get started.
I have a question. Does the
Yes,
order matter of like what way like you put it in?
good question. The order does not matter. So for instance, this is also an acceptable answer. It's the exact same thing.
Okay.
Next, we have number 2, x squared plus 10x plus 9. So for this one, again, we start with the factors of 9. This time there's two pairs. We've got 1 and 9, and we've got 3 and 3. And we also know that since this is positive right there, it means they're either going to both be positive or both be negative. And why could it both be negative? Because isn't a negative times a negative a positive? So yes, it's either both positive or both negative. Now, since the b term, the middle term, is positive 10, I know they're going to be both positive. And for that reason, I just add the numbers together. For instance, the factors of 9, 1 plus 9 is 10, which is good. 3 plus 3 is 6, so it's wrong. Use 1 and 9. So I already know the answer is going to be x plus 1 times x plus 9. And since the order doesn't matter, I could have said 9 and 1, and that's the same thing. Okay, now for the next one. We have x squared minus 4x plus 4. So for this one, again, we see factors of 4. We've got two pairs. We've got 1 and 4, and we've got 2 and 2. I also know that this is positive, which means it's either both positive or both negative. And since this is minus 4 this time for the middle term, I know they have to both be negative. And that's the rule. So I look at 1, and by the way, since they're both negative, I can say negative 1 minus 4, which is negative 5, or I can say 1 plus 4, and that's positive 5. Notice it's the same number. Either way, I'm trying to get 4, so it's not 1 and 4. I know that. And then 2 plus 2 is 4. That's the number I want. And like we said, they're both negative. So that just means 2 and 2 is the right one, but you got to make sure they're both negative. And here's a fun fact. Since these are exactly the same, another way you can write this is also an acceptable answer. You can write x minus 2 quantity squared. I don't expect you to write it like this. It's perfectly correct if you do, but I'm fine with the left. X minus 2 times x minus 2. Any questions on that page? So continuing on, we now want to talk about why does factoring matter? There's a bunch of reasons why, but the biggest reason why is because we are going to use this strategy to solve for x. Now let's look at this example. We have x squared minus 3x minus 4 equals 0. I'm so nice that I decided to factor it for us, and we got this. Now you'll see the one difference from this problem and the rest of the problems we've seen today, and ever with factoring, is that we're setting it equal to 0. Set equal to 0. This is the secret to solving for x. So factoring, yes, we know how to factor now, but if you set it equal to 0, you can actually solve for x. Let me show you how. When I have both factors equal to 0, I want to set both equal to 0 separately. What does that mean? It means I'm going to write x minus 4 equals 0, and I'm going to write x plus 1 equals 0. See how I'm setting both factors individually equal to 0? And now I have two equations, and I need to solve both. These are probably the easiest equations you'll ever see in your life. The first one is add 4 to both sides, you get x equals 4. That's one answer. And then the other answer is subtract 1 from both sides, and you get x equals negative 1, and there's your other answer. And what do I mean by solutions? I'm saying if you plug in 4 or negative 1, you'll get the equation to match. Let me prove it. The equation was x squared minus 3x minus 4. Let me plug in 4 for that, and let's see what we get. So I'm saying 4 squared minus 3 times 4 minus 4. And the question is, does that equal 0? Well, 4 squared is 16. 3 times 4 is then minus 12, and then minus 4. 16 minus 12 minus 4 is 0. It does look like 0 equals 0. We're correct. That's a solution. And of course, the other solution will be negative 1. Now, if you want to know a shortcut to solving these factors, see how it was x minus 4 and x plus 1, and the answers were positive 4 and negative 1? So it looks like the shortcut you could say is after you're done factoring, then the answer is just the negative version of the factor. So what's the opposite of negative 4? It's positive 4. That was the answer. What's the opposite of positive 1? It's negative 1. That's why negative 1 was an answer. So that's a little shortcut you can use. That's what I do. That shortcut will not work all the time. I'll show you later in today's lesson when it does not work, but most of the time it does work. Oh, and by the way, whenever that shortcut does not work, you can always do this, and this will work 100% of the time, where you set both factor equal to 0. So now we're going to continue with some examples, and we're actually going to be factoring and then using that method we just said to actually solve for x. So for this one, x squared minus 9 equals 0. If you remember, this one's a special one because it's missing the middle term. It's not really missing it. It's really just 0x in the middle. In other words, the numbers have to add up to 0, which is fine. So same thing as before. I write out my factors of 9. I've got 1 and 9 and 3 and 3. And so then I would say, well, I see the minus sign right there. That means we have one of each, one positive, one negative. And I also say they have to add up to 0. So for instance, 1 minus 9 is negative 8, so that's not good. And 3 minus 3 is 0. Yep, that's the one we want. It looks like since it's one of each, it's going to be x plus 3 times x minus 3 equals 0. And then the last thing we're going to do is, again, just do the opposite. So it looks like the opposite of positive 3 is negative 3, and the opposite of negative 3 is positive 3. And you don't have to write positive 3, you can just write 3, that's fine. And here are our two answers for this one. Now, by the way, just two more things I want to say. The first thing is, if you prefer to write it like this, x equals negative 3 comma 3, this is an acceptable version of the right answer as well. And then the last version that's also correct, you can also write x equals plus minus 3 like this. This is also correct. But you can only do that if it's plus and minus like this. So you can't do that all the time. Any questions? Okay. So next, number 2. X squared plus 6x plus 8 equals 0. Again, we're going to do the same thing. List out the factors of 8. We've got 1 and 8 and 4 and 2. And then, since they're both positive, and I know that because that's a positive and that's a positive right there as well, they need to add up to positive 6. 1 plus 8 is 9, no good. 4 plus 2 is 6, that's the one. So then I would write x plus 4 times x plus 2 equals 0, and then the answer is just the negative version of both of those. So x equals negative 4, comma, negative 2. And again, if I wanted to, I could have wrote them out separately. I could have said x equals negative 4, and then x equals negative 2, and this would be correct as well. Okay, so next we're going to talk about factoring where a does not equal 1. What's a again? Remember, a is the form ax squared plus bx plus c. Every problem we've done so far with factoring has just been a 1, an invisible 1, in front of the x squared, which means that the problems we've done so far have been the easy ones, basically. I'm going to tell you right now, these are going to be, the ones coming up, are going to be the hardest examples in all of Algebra 1 that you're going to take next year because these examples are really difficult. A lot of times it's just going to be trial and error. You're going to be trying over and over again, and a lot of times it won't work. Okay? But that's fine because as long as you don't give up, eventually you're going to get it. Okay, so a couple things I need to say. Number one, the cross method doesn't work anymore. That's the method I don't use anyway. And that's actually kind of a lie. There is a way to still use the cross method, but at that point, it's even more complicated than it was before, and I still don't like the cross method. So for this one, here's what we're going to do instead. And the first thing we're going to do is list out the factors of A and C. And then step 2, we're going to use trial and error until we get the right combination to get B in the middle, basically. So let's look at the example that we just had above, 3x squared plus x minus 2. So first, I'm going to list out the factors of C, like we've been doing. There's only one pair of factors. It's 1 and 2. That part's the same. But now we have to list out the factors of 3x squared. Now, I'm not going to write 1 and 3. I'm not, even though I just did. I'm going to erase it. What I'm going to do instead is I'm going to write 1x and 3x, because that's the combination. It's not 1 and 3. It's 1x and 3x. And the reason why is because that's what's going to be going in my parentheses. Oh, and since it's 1x, you don't actually have to write the 1. You can just write x. That's fine. And like we said before, this is minus, so that means it's going to be one of each. And we need to add up to a positive 1 in the middle. So now I know, let me write out all the combinations that it could be, and then we'll talk about which one is correct. The first combination is x. Actually, let me write it over here. The first combination we have is x plus 1 times 3x minus 2. And the second combination we have is x minus 2 times 3x plus 1. Actually, I believe there's even more than this. Another thing we can have is x minus 1 times 3x plus 2. And then the fourth combination we can have is x plus 2 times 3x minus 1. So in other words, there's 4 potential answers here. Only one of them is right and 3 of them is wrong, which is why this is going to take a while. But that's fine because we have Dan the tutor here. I'm going to help you get through these problems today. And luckily, there's not too many of these that we're looking at compared to the other ones, because I know they take longer. The other thing I want to say is maybe you're thinking right now, hey, Dan, you didn't start with the 3x. Like, for instance, why can't you say 3x plus 1 times x minus 2? Why isn't this a combination? I'll tell you why. Because we actually already did this. Isn't that the same as that one right there? And didn't we say order earlier that the order doesn't matter? So in other words, what I'm saying here is that, yeah, it looks like we already got all four. And if you rewrite it any other way, you're just going to get a different version of the ones we've already said. So that's good news for us. That means there's no more combinations. The bad news is only one of them is right. And remember, I need to add to a positive one in the middle. Now, since this is our first time doing it, I'm going to pick one at random. That's usually not what you want to do. You usually don't want to pick one at random. But let's pick the first one and let's FOIL it to see if it's right or wrong. Again, when I FOIL, I'm doing x times 3x, which is going to be 3x squared. Then x times negative 2, which is minus 2x. Then 1 times 3x, which is plus 3x. And then the last is 1 times negative 2, that's minus 2. Now these two things are like terms. They add up to a positive 1x. So we get 3x squared plus 1x minus 2. And hey, that's exactly what we wanted. This is correct. The final answer is x plus 1 times 3x minus 2. In other words, we got lucky. Now it's worth mentioning, well, what does it look like if you choose the wrong one? Let me show you an example of choosing the wrong one. Here's x minus 1 times 3x plus 2. That's the third option on our page here. And if we look at that, that's going to be this. X times 3x is 3x squared. X times 2 is plus 2x. Negative 1 times 3x is minus 3x. And then negative 1 times positive 2 is minus 2. It looks like we get 3x squared minus 1x minus 2 as our final answer. And remember, what did we want? We wanted 3x squared plus 1x minus 2. So here's a shortcut for you. As soon as you see that you got like very close, but it's just the negative version, then all that means is you need to switch the positive and the negative. So for instance, x plus 1 times 3x minus 2, you flip the signs, now you've got the right answer. And again, you can always check by foiling. And if you choose any of the other ones, like for instance, x plus 2 times 3x minus 1, well, this one's going to be completely off. I'm just going to save you the time. I'll tell you, if you FOIL correctly, you get 3x squared plus 5x minus 2, and this isn't even close to what we wanted because we wanted this. So whenever that happens, it means that you don't want to flip the sign. You want to choose something else entirely. And so that's some shortcuts so that we can get very good at narrowing down our options. But as you're going to soon discover, there are a lot of variations that we need to watch out for. Okay, so let's do number 2. Number 2, we have 3x squared plus 5x minus 2. As a matter of fact, if you look here, it's the exact same first term and last term. In other words, listing out the factors of 2, I've got 1 and 2. Listing out the factors of 3x squared, remember I'm going to say 1x and 3x. And again, that order doesn't really matter. And the funny thing is, the 4 options that we can have are the exact same 4 options that we just had a minute ago. In other words, it's x plus 1 times 3x minus 2. We have x minus 1 times 3x plus 2. And why is this? Because this is going to be all the combinations you can have of 1x and 3x and 1 and 2 if the 2 has one positive and one negative. So the next combination would be x plus 2 times 3x minus 1. And then the last combination is x minus 2 times 3x plus 1. As we said before, there are 4 combinations that could be correct here. Any one of these could be right. And actually, I'll kind of just save us the time since we already did it in the last page. Remember right here when we got 3x squared plus 5x minus 2, and that's what we wanted? So it looks like this is the right one. And again, if you chose any other one, you would have gotten the wrong answer. And if you had the signs flipped, in other words, if you said x minus 2 times 3x plus 1, then I can tell you it's the exact same answer, except instead of plus 5x, we would have had minus 5x, and then you just know you need to flip the signs with the negative 2 and the positive 1. So final answer is x plus 2 times 3x minus 1. Any questions? Okay. So as you can tell, this is harder, obviously, but hopefully it won't be too bad after we do some practice like what we're doing right now. So for the next one, number 3, I'm going to give you a piece of advice for number 3. My piece of advice is we can make the problem easier by getting rid of the negative in the first spot. What do I mean? Basically what I'm saying is I typically don't like to start out with a negative a. And remember, a is the first one. I like the first one to be positive, and if anything, c can be negative, that's fine. I've seen c be negative and positive before. I don't care. I'm very good at that. So how do I get rid of that negative? There's only one way you can do it. You divide everything, and I mean everything, by negative 1. And when you do that, let's see what we get. You get positive x squared. Then you have 4 divided by negative 1 is minus 4x. And then 5 divided by negative 1 is minus 5. And by the way, whenever you divide by negative 1, the way you account for that in your equation is you need to put this whole thing in parentheses, and then you put a minus sign out in front. Technically, it's not just a minus sign, it's a negative 1. But as I said before, you don't need to write the 1 in this case because it's multiplication. By the way, if let's say hypothetically I divided everything by negative 5 instead, then I would pull out a negative 5 like this, and I would write the negative 5 out in front. But there was no 5. I'm just saying that as an example. This is correct so far. And the reason why I would do this is because now it's the same thing we've been doing. In other words, write out the factors of 5. There's only one pair. It's 1 and 5. That's a minus sign, which means it's one of each, one positive, one negative. And then the factors of x squared, there's only one pair. It's 1x and 1x. And again, you don't have to write the 1. I'm just showing you for now. But again, how many combinations do I have this time? It looks like I have x plus 1 times x minus 5. And then I have x plus 5 and then x minus 1. And that's the only combinations you have. You can try others. You'll notice any other version is just the same thing as the 2 I wrote. For instance, if I wrote x minus 5 times x plus 1, that's the exact same thing as the first one because the order doesn't matter. So this is nice. We've only got 2, which means I have a 50% chance of getting the right answer. Let's try the top one. Let's FOIL it out and let's see if we get the right answer or not. So x times x is x squared. X times negative 5 is minus 5x. 1 times x is plus 1x. And then 1 times negative 5 is minus 5. It looks like x squared, negative 5x plus 1x is minus 4x. And shoot, we wanted positive 4x. That's okay. That just means the other one's the right answer. And you don't even have to FOIL it because you know it's the right answer. And that'll save you some time. Oh, and by the way, that's not the final answer. I shouldn't circle that. The final answer is x plus 5 times x minus 1, but with that negative sign out in front right there that we said we needed earlier. And where did that negative sign come from? It came from the fact that we had to divide everything by negative 1. And now we're good. Any questions?
Yes.
Go ahead.
So I'm very confused. Okay. So I get everything but like the combination part.
Okay, can I ask you, did the first two problems make sense? Or is it just this third one that's giving you trouble?
The third one.
Okay. Does it make sense that is the negative sign the thing that's confusing you or no? The negative
Yes.
one out in front.
Yeah.
Okay. So why did I do that? First of all, I did it because that just made the problem easier for me. In other words, I take the negative sign out, and then what did I do? I divided by negative 1 for everything, and
hmm
now I have this. Does that make sense so far?
Uh, sort of.
Let me
I just
prove
don't
it.
get how like.
Let me prove it.
Okay.
Let me show you something. Here's the problem, right?
hmm
And this is what I did, and then it became this. Now let me show you why this is the exact same thing as the thing I wrote originally. Because technically this is a negative 1 out in front, and we know how to distribute,
Mhm.
right?
Yeah.
So when I distribute this, it's negative x squared. Negative 1 times negative 4 is positive 4x. And then negative 1 times negative 5 is plus 5. And now it's the original.
Oh, got it.
Yep. And by the way, this has a name. This is called GCF. In other words, greatest common factor.
Okay,
And what was the factor? The factor was negative 1 that we pulled out.
got it. That makes a little bit more sense.
Glad to hear it. Again, you just have to practice. You will get it eventually. Don't worry.
Okay.
So that's it for number 3. Next, we have number 4. For number 4, same thing we have been doing, except I'm going to tell you right now, this one has a lot of combinations. So for this, first of all, what are the factors of 4? We've got 1 and 4, and we've got 2 and 2. The fact that that's negative means, again, it's one of each, one positive, one negative. And here with the 5x squared, I would say that we've got two options. We've got 5x and x. Actually, that's just one option. Yeah, we've got one option. It's 5x and x. Okay, so now I'm going to list out all the combinations we can possibly have. There will be 6 total, and you don't have to know the total number or how I calculated that. All you need to do is write out the combinations. In other words, the first combination can be 5x plus 1 times x minus 4. That's one combination. Another combination I can have is 5x minus 1 times x plus 4. That's good as well. The next one I'll say is 5x plus 4 times x minus 1. Notice I switched the position of the 1 and the 4. And then we can have 5x minus 4 times x plus 1, flipping the signs. There's 2 more to go because we have the 2 and the 2. We have 5x plus 2 times x minus 2, and then we have 5x minus 2 times x plus 2. And notice in other problems there could be as many as 8 different combinations, but the good news is if you swap the positions of the 2, it's the exact same thing because it's still a 2 and 2. So luckily we got lucky with 6. Now the bad news is we have 6 to try, and that's like a lot of different combinations. Now let me just tell you the ones I'm ruling out in my head so I don't have to test them. And what do I mean by ruling out in my head? Well, here's what I'm going to do. I'm going to look at the inner and the outer. I'm not even going to do the last and the first. In other words, when it comes to foiling, right? Foiling is like first, outer, inner, last. I'm saying you don't even need to do that. I'm saying you just need to check the outer and the inner because you're trying to get negative 8 in the middle. So in other words, 5 times negative 4 is negative 20x. 1 times x is plus 1x. That's going to be minus 19x. That's not what we want. So that one's wrong. And remember what I said before, when I flipped the signs, that just means I would have then positive 19x instead of negative 19x. Still not what I want. I just eliminated 2 options. Fantastic. Next, I'm going to do these two. So 5x times negative 1 is negative 5x, and 4 times x is plus 4x. Notice that gets me negative 1x. Again, I wanted negative 8, so it's not this one. And it's also not the one below it because that's the same thing, but the signs are flipped, so I would get positive 1x instead. Again, not what I want, which means it must be one of the last two. And look how much time we saved. Like we did this already in like less than a minute, and we eliminated 4 answer choices. So for the last one, we have 5x times negative 2, that's negative 10x. And then 2 times x, that's plus 2x. And that's the one we wanted because we're getting negative 8x. So in other words, the final answer, well, not the final answer, this problem is really hard. 5x plus 2 times x minus 2, these are the factors. The factors. Remember, see how this is equal to 0? Whenever you have it set equal to 0, I actually want to solve for x. And if you remember what I said earlier, it's just the negative versions. However, that's not going to work for this one because this isn't x plus 2 times x minus 2. This is 5x plus 2 times x minus 2. Let me write it on a blank sheet of paper so I have more room to write. We had 5x plus 2 times x minus 2 equals 0. So what I'm saying is The x minus 2, that's fine. X equals 2, that part stays the same because it's just a 1, an invisible 1 in front of the x. The 5x plus 2 is going to be the hard part. What I'm going to say for that is set it equal to 0. That means 5x plus 2, that factor, equals 0. And now we have to solve a simple equation. Subtract 2 from both sides first. So 5x equals negative 2. And then we'll divide by 5. So that means x equals negative 2 divided by 5. Yes, this is a fraction. Oftentimes kids are afraid of fractions, but I'm not, because this is our final answer and you don't need to simplify it. This is right. You don't need to plug it in your calculator. You don't need a decimal. This is the right answer. X equals 2 and x equals negative 2/5. And I know that was hard, but are there any questions on that one? And if you do have any questions, you can always rewatch the video and it will usually, almost certainly, make sense the second time around. Or at least more sense. It won't make less sense. That's a promise. Now for number 5. For number 5, it's another equals 0 problem, which means I'm going to have to eventually set it equal to 0, like we said. And also I noticed something else that these guys have in common. I noticed that every number here is divisible by 4. That's a way to make my problem easier. Let me show you how. So if I divide each of these by 4, divide by 4, divide by 4, divide by 4, then what I'm left with is 4 over 4 is just 1, so x squared. 16 over 4 is 4, so plus 4x. And then 12 over 4 is 3, so plus 3. And now that equals 0. But remember, whenever you divide everything by 4, you need to put the whole thing in parentheses, and then you multiply by 4. That's the rule. And by the way, you can always get back to the original problem by distributing the 4 back. And if you do that, you get 4x squared plus 16x plus 12. And it's exactly what we started with. So now we need to factor this. The good news is this is easy factoring. Why do I say easy factoring? Remember how this has the invisible 1 out in front? That's when we don't need to do the A and C method. You can just do it what we did last week and the beginning of today. In other words, the factors of 3 are 1 and 3. And you don't have to list the factors of x squared because it's done for us. So now I know that this is positive, which means they're either both positive or both negative. And I know it's plus 4, which means I guess they're both positive. And immediately I have the answer. I know it's going to be something x and something x. If you forget why, that's exactly what we did in the beginning of this lesson. You can even rewind the video and see for ourselves. And then I know it's going to be plus 1 and plus 3. And that equals 0. And don't forget the 4 out in front. That 4 comes along for the ride. Do not drop it. Now, the good news is it's not going to change the answer, that 4. It's actually going to be gone in a second. So how do we get rid of that 4, right? The good news is you don't have to get rid of it. It literally does not matter. But if you really want to get rid of the 4, then you have to divide both sides by 4. And what's 0 divided by 4? It's still 0. So in other words, we have x plus 1 times x plus 3 equals 0. Still, it looks like the 4 doesn't even matter. And then for this one, remember this is the negative version to get the answers. In other words, the opposite of positive 1 is negative 1, and the opposite of positive 3 is negative 3. There's our two answers. Easy as that. And I shouldn't say easy as that, because I know this is literally the hardest stuff in all of algebra. So I'm going to give you a little secret. The rest of the homeworks and after this week, the rest of the weekly lessons is not going to be as hard as this one. It's not going to have the weird factoring, the really hard factoring. Any factoring problem from here on out is going to be easy factoring, unless I forget and I do put a hard factoring problem in. But even if we do see a hard factoring problem, it won't be as hard as today. I promise that. Okay, number 6. The first thing I would ask myself, based on the last question, is there anything I can pull out to make this problem easier? Are all the numbers divisible by 3? The answer is no. So it looks like I can't pull out a 3, but I can pull out that negative sign by dividing everything by negative 1, and negative 1. So what that means is I will then have positive 3x squared plus 32x, and 11 divided by negative 1 minus 11. That equals 0. And of course, don't forget to put the whole thing in parentheses and put the negative 1 out in front. Or you don't even have to write the negative 1, you can just write the minus sign, and that's correct as well. Bad news for us, this is hard factoring again. So I'm going to say the factors of 11 are 1 and 11. There's only one pair. The factors of 3x squared, remember that's going to be 3x and x. Or you can say 3x and 1x, that's the same thing. And then this is minus 11, which basically means it's one of each again. So it's either going to be positive 1, negative 11, or positive 11, negative 1. And now I need to write out all the different combinations. So for instance, there is 3x plus 1 times 3x minus 11. There is 3x minus 1 times, oh, not 3x, I apologize. Let me erase that 3. That was just supposed to be an x, sorry. So the second one, 3x minus 1 times x plus 11. The third one is, or is that it? That actually might be it. Nope, I'm wrong, sorry. It's 3x plus 11 times x minus 1, and then 3x minus 11 times x plus 1. Okay, so it looks like we have 4 combinations to choose from. Again, I'm going to be using that shortcut method we did earlier. What was the shortcut method? I look at the inner and the outer, and I just need to get to a minus 32, actually, sorry, positive 32, because we already pulled out the negative sign. So I need positive 32x in the middle. So 3 times negative 11 is negative 33x, and then plus 1 times x is plus 1x. That's going to give me negative 32x, which is what I had in the original problem, but since I switched it, I need positive 32. In other words, this one's wrong. The good news is, since I had negative 32x and I wanted positive 32, I know the version where I flip the signs will work. I know this version is going to be the right one because I flipped the signs. If you don't believe me, you can FOIL it. You will get positive 32 in the middle. So now, let me write it on a different sheet of paper. 3x minus 1 times x plus 11 and equals 0. And don't forget the minus sign out in front. All that's important. And then how are we going to solve for x? Basically, I'm going to ignore the negative. It really does not matter. All I need to do is say 3x minus 1 equals 0 and x plus 11 equals 0. Now, technically, I didn't have to do this for the x plus 11. I could have just said x equals negative 11 because it's the opposite rule, and we're done that. But I do have to solve 3x minus 1 equals 0, and that's not too bad. So all I need to do is add 1 to both sides. 3x equals positive 1. And then we're going to divide by 3, and x equals 1/3. And there is our 2 answers for that one. Any questions? Okay. And then it looks like we just have one more for today, and then we're done, the hardest lesson of the 8-week course. We have 9x squared plus 6x minus 24 equals 0. Again, the first thing I'm going to do is I'm going to ask myself, do any of these terms have everything in common? For instance, I can't divide by 9. Like, let's see what happens when I try and divide by 9. The 9 works in the first spot, but 6 is not divisible by 9, and 24 is not divisible by 9. So 9's not going to work. 6 is not going to work either. 24 is not going to work either. But there is a number that will work. You can divide all of these numbers by 3. Let's see what happens. 9 divided by 3 is 3x squared. 6 divided by 3 is plus 2x. And negative 24 over 3 is minus 8. That equals 0. And don't forget, put this whole thing in parentheses and then put the 3 out in front. This is the 3 that you divided everything by. Now, unfortunately, this is still going to be hard factoring because the 3x squared is the first term, but that's okay because we've been doing this all day. So the factors of 8, we've got 1 and 8, and we have 2 and 2. And I know that the factors of 3x squared are going to be 3x and x. So now let's write out all the combinations. It looks like I'm going to have Oh, I forgot to mention, that's minus 8, so it's one of each. So anyways, the combinations we can have are going to be 3x plus 1 times x minus 8. We have 3x minus 1 times x plus 8. The next one is 3x plus 8 times x minus 1. And then we have 3x minus 8 times x plus 1. Still, we need to get the 2 and the 2. We just finished the 1 and the 8. So the last two are going to be 3x plus 2 times x minus 2. And the last one is 3x minus 2 times x plus 2. 6 different versions it can be. By the way, technically you don't have to write out all 6. If you have a feeling that you know it's the first one, for instance, you only have to write out the first one and test it, and if it works, then you're done. But I'm writing out all 6 because this is good practice, and because this is me explaining the whole thing, not just the shortcuts. So anyways, let's test out the first one. We need a positive 2 in the middle, it looks like. So I do the outer. 3 times negative 8 is negative 24x. And then plus 1x in the middle, so plus 1x. That's going to be minus 23x. That can't be right. I want a positive 2x in the middle. So I know that's not right. I also know the next one's not going to be right because that's going to get me positive 23x. It's just going to flip the sign. So that's wrong. Next, let's try this one. So 3x times negative 1 is negative 3x. 8 times x is plus 8x. That's positive 5x. Again, not what I want. I want positive 2x. And I know the one below that is going to be negative 5x, which is also wrong. So it's one of the last two, it looks like. So first I do
How'd you get the
outer.
two twos?
Sorry, what'd you say?
How'd you get the two
Yes, because
twos?
the factors of 8 are also 2 and 2.
2 and 2 is 4.
Oh, yeah, you're right. That was horrible. Thank you. So
Here's okay.
that's why I always like a live audience because they can catch my stupid mistakes. So yes, it's 2 and 4. Yes, that's going to change the factors. We actually have two more that we have to worry about. We've got this and this. I'm going to write these on the next page because I'm already running out of room. It's 3x plus 2 times x minus 4, 3x minus 2 times x plus 4, and then 3x plus 4 times x minus 2, and 3x minus 4 times x plus 2. Yeah, I would have figured it out, I guess, in a second because we would have had no right answers, and I would have probably checked my work. But it's always good to check your work, of course. Anyways, 4 more to test. Hopefully it's the next one, because I don't feel like testing all 4 of these, but I am at the mercy of Lady Luck right now. So 3 times negative 4 is negative 12x, plus 2x. Looks like I'm going to get minus 10x here. Again, wrong. And it looks like the next one's wrong too, because that would get me positive 10x, because I flipped the signs. And there was only one combination left, so this was not intentional, but it looks like it will be one of the last two. 3x times negative 2 is negative 6x plus 4x. That's plus 4x. So that's going to be negative 2x. I wanted positive 2x. I can't believe it. It's the very last one. It's going to be 3x minus 4 times x plus 2. Now, don't forget, this is technically, don't forget the 3 out in front. It's 3 times 3x minus 4 times x plus 2 equals 0. And then I just have to set both equal to 0 and solve. So what I mean is 3x minus 4 equals 0. I'm going to add 4 to both sides. So 3x equals 4. And then I divide by 3. X is equal to 4/3. That's one of my answers. And then the other answer is easy because it just uses the negative rule. And x is going to be negative 2. And we're done. Any questions?
Yes, I have one question.
Yes.
The way that we did it, like for like number 6, where it's like we set them both equal to 0.
Yes.
Can you do that for like all the problems?
Yes. The reason why
Okay.
I didn't do that here is because if I do, let's say I say x plus 2 equals 0, subtract 2 from both sides, x equals negative 2. It's the same answer, just slightly slower. So what I'm saying is
Um,
the answer is negative 2 because of the opposite rule. What's the opposite rule? Let's go back to the very beginning of the lesson. right here. All these problems, this is page, what page is this? Page 3? This is page 3 from the, oh, sorry, page 2. This is page 2 from the packet. And basically, what I'm saying is that this is easy factoring on this page. It was easy factoring. In other words, it was just x squared. And what we did
Yeah.
was, when we have x plus 3 times x minus 3, it's just the negative answer. Same thing here. When it was x plus 4 times x plus 2, it was negative 4 and negative 2. The only time you have to set it equal to 0 is when it's not x. It's 3x, 2x, 5x, something like that. But if it's just x
Oh,
plus 2,
got
x
it.
minus 1 million, as long as it's an x out in front, that's when you do the negative rule.
Got it.
Great. So then if there's no other questions, then we're done for today. Of course, there's the homework. If you do have any questions, don't be afraid to email me or anything like that because I'm always happy to help. I know this stuff's hard, and I'll be posting the solutions in a few days. So thank you all for watching. I hope you have a great rest of your day, and I'll see you next week. Bye-bye.